Isn't it tough to have to memorize so many derivative formulas and then you show up at your test and you're like, I forgot. Well, here's how you would solve this quickly if you forgot the inverse sine hyperbolic function's derivative formula. What I'm going to do here is, just like in the video above, don't always just jump into finding a derivative. Sometimes you might want to actually rework the problem so the derivative itself is way easier. Because we have that y is the hyperbolic sine function's inverse here of 3x squared plus 1, this part here I'm going to call sinh. That's what I learned in school. Tell me below if you pronounce it differently around the world. What I would do here is I'm going to first rewrite this as sinh of y equals 3x squared plus 1, because we have rules about inverse functions, right? And what's nice about this is, yes, it looks like y is no longer by itself, and we're complicating things, but that's okay because that's what implicit differentiation's for. I talk about this in other videos, and it's not as bad as it looks because now when I take the derivative of both sides of the equation, we have this expression. And where many students might be getting stuck on this is, okay, the right side here is easy, but the left side here, well, what do we do? And if you remember, and maybe you haven't learned it yet, because sinh of y has a y in it due to the chain rule, just take its derivative like you normally would, which would give you the hyperbolic cosine function, which is Cosh of y, but then it needs to be times dy over dx, right? Because of the chain rule. And so you would get this here. And what you would do next, like any equation, is because we're trying to solve for dy over dx, I would just divide both sides by cosh of y. But here's a little bit of a curveball for you. What if I told you that this answer isn't good enough? With normal functions that have an implicit relation, like a circle, for example, it's okay to leave y in your final answer. But here, what if I told you your final answer should only be in terms of x? Think about it for a second. Let me know if you see it. Okay, so also what's really nice about our trigonometric identities, there's a good one to remember for these hyperbolic functions, right? If you have this identity here, what you can do is, since we're dealing with cosh squared of y in the identity itself, but here we have cosh of y, why don't we just rewrite this identity and solve for cosh squared of y, and then take the square root? And before I take the square root of both sides, is that okay? Think about the domain. Do we have to worry about any domain restrictions? Okay, so if you don't remember for Cosh, remember that for all values of y in this case, it's always greater than or equal to 0. So we're just going to take the principal root, and we are okay here to have this expression where I took the square root of both sides. And then when I plug it back into my dy over dx we found above,